Hey folks, this is Michael back with a little project I've been working on for a little bit. This is one comes under the category of convenience or ease of use. You've probably all seen this before. You've got your microcontroller going to your breadboard, doing your little wiring stuff, and as you can see with my circuit here, I moved my wires around and something's wrong. So the circuit tends to be delicate. The other problem is if you want to work on different projects, you've got to unplug this, and then you've got to work on your other project and plug it back in if you want to use this. And, I don't like doing that. Of course, your other choice is, you just buy another Arduino, and keep buying Arduinos and stuff, but that can get expensive and still doesn't solve the problem of portability and stuff and moving things around on the desk when they get messy. The other idea I came across with was, all right, let me just build my own Arduino circuit. And this is a fairly complicated circuit here. This one's pretty involved. For another time we'll talk about it, but the point is that I had to build a bare bones Arduino circuit so that I could build my other circuit. And while this works fine, I don't think I want to do that for every project. This board's been around for about a year and a half, constant refinements and learning things. But I don't want to build an Arduino circuit every time I want to do one. So that really didn't work for me for lots of projects. So the other choice was, well, go buy a shield that plugs right in. That works, I could do that. The problem is that, it doesn't hold the bigger breadboard. Okay, a 400 point tie breadboard here, that's what I use. Or, you solder everything, but I don't want to do that either. I don't want to solder things and unsolder them for prototyping, because to me, prototyping means change. So I said, okay, fine. I'm going to build my own circuit. I'll build my own shield. And that's what I did. So I came up with this. Okay. So this is a shield that will hold a 400 tie breadboard, like so. See? It can even hold the longer version of this, although that might be a little bulky, but there might be a need for it. You never know. Some of the stuff I'm working on, that might need it. But, as per usual, it plugs right in to the bottom of the Arduino. It's laid out so you can see the shape of the Arduino. I've got all the pins and everything lined up. I've got a reset button, and I've got two extra buttons with two LEDs already pre-wired to resistors to ground, so that if you just need a button and an LED, all you have to do is plug your Arduino in. You don't even need the board, So it makes life really easy. And here's an example of what I mean by that. So here's a project that I'm working on. This is a RealTime Clock circuit. I've got an LED here, and I'm driving the LED pins directly as opposed to using a driver. And I know you can use a driver, but I have my reasons for that. But essentially, so what I can do is just plug this guy in and get my pins lined up here. This Arduino has been through a lot, so it's got a... Alright, so I plug that in, and then I plug in my circuit, and there's my clock. And it's keeping time. It's 10:30 a.m. So that's working just fine. As I begin doing stuff, I may need this Arduino for something else, So what I'll do is I can unplug this, pull my Arduino off. Before I plug in my new shield that's wired differently, let me upload the circuit for that one. All right, easy enough to do. I should say sketch, not circuit. So get that uploaded, and okay, looks like it's uploaded. I'm going to unplug it for good safety, for proper safety when it comes to circuitry. I don't want to short anything out. And I'm going to plug this guy back in and plug this in, and there we go. So this is a different circuit that I'm working on in conjunction with the RealTime Clock. So this is a stepper motor, stepper driver. This is an LED. This LED is driven by a chip on the bottom side of it, and I even have a servo that I haven't finished working on yet. But as you can see, I have an entirely different circuit running here. Or I should say sketch, but circuit too. And in this case, this is a stepper motor that's going clockwise to 249 and then counterclockwise back to 0. It's still prototyping, it's still in development. But the point is I'm able to switch back and forth between that and this in a couple of seconds, less than a minute. You know, basically the amount of time it takes to unplug it, load the sketch, and then plug it all back in. Very easy to work with, very convenient, you know. Even if you want to have multiple Arduinos, you still have the portability stuff. You know, I can still move this around easy enough. You know, I still have a little bit of problems with the wires, but I don't have to worry about, you know, the wire coming away from the breadboard and getting pulled out. If anything, just me catching the, you know, the wire, it makes it easy. The other thing I'd like to point out is, you know, I have a Spark Fun board. You know, I do have the Mega board that I showed you. You know, and of course there's an Arduino on this one. You know, and you keep buying these things, money's going to rack up. The other problem that I run into is that this is a Chinese knockoff of an Arduino Mega. Can't, for some reason, upload sketches to it from my Mac, but I can from Windows. So the board works, but my Mac machine doesn't like it. I'll have to figure out why. This one here works fine, except there's some sketches I load on this that don't work the same as they do on the Arduino, on the Uno. So again, these are not terrible things, but they detract from working on the project, and I don't want to have to worry about bouncing back and forth and debugging things. I want to switch gears, work on a project, and switch gears, because that's, you know, that's what we do. You know, and if you don't have a super neat desk, I am kind of obsessive about my wiring, but if you're not super neat on your wiring, you can end up getting disconnected. You know, these jumpers, they're okay, but you know, they don't last, and they're not really the best, especially if you're moving stuff around. Okay, so that's what I did, working out good. Let me give you a quick tour of this, and then I'm gonna sign off here. But again, here's the complete breakdown. I showed you I've got two buttons that are not wired to anything. They're just wired to four pins on this header, and then the two LEDs, the positive side of the LEDs, are wired to the last two pins, and they're pre-wired to the appropriate size resistor. I even have a reset button up top, and it's a lower height than the other two, so that as you're fumbling around, you don't actually accidentally hit the reset button. And of course, there's a power LED, and then there's a yellow LED that's wired to port 13, so you know, you can see the activity going on it. Here, let me show you this real quick. Let me pop this off. I'm going to pop that off. I'm going to put my clock circuit back on, because this one I actually have wired. One of the things I did was I wired up the ICSP pins here. As you can see those. Okay, they're wired up to this pin, and although it's not really all that necessary from a convenience point, it really does make a lot of sense, because these wires are wired to this header, which is wired to the ICSP, but if I hadn't wired them, I'd have to stretch these wires all the way across the board over here. So this isn't adding additional functionality by having this here, this you know, having this pin set here, but it certainly makes it a little bit more convenient, so I'm trying to reduce wires running across the board. But again, so let me show you one other thing I did. Now, before I power everything up, again, good practice, you know, upload the sketch first. Doesn't take that long, so why take the chance of, you know, shorting anything out? And upload done. We'll disconnect. Now I'll plug my circuit back in. I've even got the outline of the board, so if you have any questions, you know, I even have all the pins laid out so that you can see which pins are which on both sides, top and bottom. So we'll go ahead and plug this guy back in. Now I'm going to plug my circuit in, okay? And we're back in business on my clock, but what I was going to show you is the pins, see? I have one of these, yep. See, I have it wired to the green button, to the green LED, and if I wanted to wire it to the blue LED, I just switch it over. There it is there, pretty bright too. I even have the reset button. Okay, but, you know, RT breakout, our real-time clock breakout, and the clock, everything's working. Pretty cool, huh? Alright, well, guys, hope you like it. There's details down below in the header and the body of the YouTube listing. If you like it, give me a thumbs up. If you got any ideas or thoughts, any feedback, love to hear it. Thanks, guys. Have a good one. Bye.